Okay, guys, so this lesson is on the Pythagorean theorem. I know you've heard of it before, a squared plus b squared equals c squared, but we're going to actually apply it and use it in the real world and go deeper and proof it for using the distance formula. If that didn't make sense to you, don't worry. We're going to use a lot more of it and it'll make sense later. Okay, so these are some definitions that you need to write down because you need to know the distance formula, what the hypotenuse is, the legs, Pythagorean theorem, what a Pythagorean triple is, and what a right angle is. You're going to be expected to use this math vocabulary in class and to understand when I say it. Okay, so this is an example of a right triangle. So what we have on our right triangle, we have our leg and our leg. Now, it doesn't really matter if this leg is A or this leg is B, or if this leg is B and this leg is A. So another vocabulary word for you is interchangeable. The legs are interchangeable. Doesn't matter which one is A, which one is B. However, the hypotenuse, it is very important that the hypotenuse is in the proper place because your C has to be your hypotenuse. Your C can't be a leg. And how do you know where the hypotenuse is? The hypotenuse is always adjacent to the 90-degree angle. So directly across from the 90-degree angle is going to be your hypotenuse. Now, so let's do some examples. So as I said before, the Pythagorean theorem is a squared plus b squared, and lose my 2, equals c squared. So now you see why your c has to be your hypotenuse, because a plus b equals c. So a plus c can't equal b. That's not how it works. So let's do a triangle where a is 10 squared, or a is 10 rather, I should say. It'll get squared eventually. And b is 24. So now we're looking for c. How do we find c? We plug all of our numbers into the Pythagorean theorem. So our a is going to be 10, so we're going to do 10 squared. Our b is 24 plus 24 squared. And we don't know what our c is yet, so it's still c squared. So from this point, it's really just combining like terms and doing the math. So 10 squared is 100. 24 squared is 576. And all of this equals c squared. It's very important to keep the square with the c. So 100 plus 576 is 676. Now, 676 equals what? C squared. Now, we still don't know what c is because over here in our problem, we don't have c squared. We have just c. So we have to figure out what c is. How do we figure that out? What's the inverse operation of squaring something? You guessed it. You take the square root. So we're going to take the square root of 676 and the square root of c squared. The square root of 676 is 26, and the square root of c squared is c. So our answer to c, what is c? C is going to be 26. So now we have our second example. In our second example, a is 9 and c is 13. So we're still going to use the same formula. Okay, so we're still going to use the Pythagorean theorem. A squared plus b squared equals c squared. Now we're just plugging in different places. Instead of having b, now we have c. So it's going to be 9 squared plus b squared equals 13 squared. What's 9 squared? 81. So now we have 81 plus b squared equals 13 squared, which is what? 169. So now this is how we solve a one variable equation. We just need to separate the numbers from the variables. So we're going to subtract 81 from both sides because it's our inverse operation. Excuse me. And 81 minus 81 is 0. We don't need to write that. So we're left with b squared equals 169 minus 81, which is 88. Took me a second to think about it. So our b squared is 88. So now, how do we find out what b is? Because here, we don't have b squared, we have b. We do the inverse operation. You are correct. So we're going to take the square root of b squared and the square root of 88. So we're going to have b equals, and 88 is not a perfect square, so our number is going to be 9.38. So our b is 9.38. So here we can fill it in with 9.38, and that's an estimation because 88 is not a perfect square. On to our next example. In this example, we have b and c and no a. So our b is going to be 18 and our c is going to be 30. So we're still using the same formula, a squared plus b squared equals c squared. This time we just don't have a. So we're going to leave a as a squared because we don't know what a is. Plug in our b, which is 18, and our c, which is 30. So now we just solve it like we solve any other one step or one variable equation. We're going to do the inverse operation. And since this is positive 18 in addition, we're going to subtract. We need to know what 18 squared is first. 18 squared, we have a squared plus, and 18 squared is 324, and 30 squared is 900. We would have had a hard time subtracting 18 squared from 30 squared. But now we can subtract. So now we can subtract 324 from both sides. So 324 minus 324 is going to be 0. So we're just going to be left with a squared on that side. And on the other side, we have 900 minus 324, which is going to give us 576. A number that we've seen before. So now, how do we get rid of the square? Or what's the inverse operation of squaring something? Yes, you guessed it. We're going to take the square root. So let's take the square root of a squared, the square root of 576. And we're going to be left with a equals 24. So in this case, our a equals 24. Now I'm just going to show you a couple of images just to kind of get you thinking about the Pythagorean theorem, how it proofs, and how it might relate to the distance formula. Well, that's all, guys. Remember, if you have any questions, be sure to put them on the blog. Have a good evening.